This is Drives Direct in Nottingham. We're just showing you here a digital rotary phase converter made by Digi Phase. This came into us as part exchange against a digital phase converter because the customer complained that it was too noisy and too power hungry, and they were having problems connecting it because it was causing the neighbours' lights to dim. So we just wanted to do a quick test on it, and we've got it connected up now on a test rig. We've got a meter monitoring the input amps, we've got a meter monitoring the output current, and we've got a test load which is a 5 horsepower motor. So this is a 15 horsepower rated unit. It's about 2 foot square and weighs about 80 kilos. I'm just going to put the power onto it now. We're connected to a 100 amp power source, and the meter's come up showing the amps. You can flick a switch there and the meter will show the mains voltage. This fluke meter is now set to monitor the inrush current because the customer was complaining that they were having breakers tripping and the lights were dimming. So we've got it set now to measure the starting surge and see how much power this takes when it's actually running. Okay, I think what the customer said about the noise was true, because we're having to raise our voice now to speak. And the meter here is showing that the starting surge was 440 amps. And that went on for getting on for half a second before the amps then dropped back to 19.5. So considering there's no load connected, it's a heck of a lot of power that the unit's actually taking at the moment. I've got a separate ammeter looking at the input power, and that's confirming the calibration of the meter, showing that we are actually taking 19.2 amps. If I switch back to the voltage, it shows us that main voltage is still around 230 volts. Now, I'm going to have a look at the meters now showing the output. On the top row of meters, they're showing the voltages between L1 and L2, L2 and L3, and L1 and L3, and they're all roughly right at just over 400 volts. One thing that is noticeable, which is a bit worrying on this, if you look at the bottom set of meters, this is the neutral to phase voltage. On neutral to L1 we've got about 180 volts. Neutral to L2 it goes way over 300 volts, and we're not able to see exactly what that is. And the third meter, neutral to L3, that's about right at 220. There's no load actually on there at the moment, so what I'm going to do is, if I press the start button here, that will start up a regenerative blower which is 5 horsepower, so we'll see what happens there. Okay, now the phases have maintained balanced, the neutral voltages haven't changed. The actual converter itself is now drawing 25 amps, so not much more than it was drawing off load. Now we're going to check on the fluke meter now to see exactly what's happening. That's showing we've got L1 to 2 at 406 volts, L2 to 3 at 420, and L3 to 1 at 422. And what we can do is we can actually set this meter to show us the waveforms and the phase shift. Okay, now the 3 waveforms are looking fairly good. If you can see, there's a little bit of notching on the top, but that could well be to do with the phantom phase and the capacitors charging. If we look at the vector diagram on this, we can see the phase shift between 1 and 2 is 118 degrees, 2 and 3 is 121, and 3 and 1 is 122, so there's no problems there. So the main points here then are that we have got a very noisy unit, and the power consumption is very high even when the unit's off load. That's around 19.5 amps. And you can imagine why this customer didn't want to use this to power a biomass boiler. They were going all out to save money. Just from the running cost of this, running 24/7, would have been absolutely horrendous, and they would be negating anything they were trying to save by going green and using a biomass boiler. The digital phase converter that they've now got is half the size of this unit. On load, it's running at about 95% efficiency, and offload, it's taking only 56 watts. And the digital unit is only is completely silent, so there's a massive difference. A little update here on the neutral voltages coming from this Digi Phase Rotary Phase converter. We were a bit concerned that the analog meters, one of them was running way off scale, one of them seemed to be very, very low, and only one phase to neutral voltage appeared to be correct. So we've now set up a Fluke power quality analyzer to have a look at this, and that's confirmed the results of the analog meters. And in this case, L1 to neutral, we were getting 182 volts. L2 to neutral was very worrying at 350 volts approximately, and L3 to neutral was the only one that's correct at 240 volts. Obviously anything connected between L1 and the neutral is going to be getting much less voltage than it needs, and that's like to cause problems, maybe with contactors rattling and other underperforming items. But if anything was connected between L2 and neutral, especially with biomass boilers where they have sensitive electronics, that 350 volts being fed onto a 240 volt circuit could very easily burn control cards out. So in that case, this type of phase converter system I wouldn't have even thought would be suitable for running CNC machines because of this phase balance. There are ways around it. We can put separate transformers in there to give a balanced neutral, but basically if you need a correct voltage on the neutral and the phases, the best way is to go digital.